Good afternoon, everyone. Today, we're exploring a topic essential to modern policymaking: text preprocessing techniques. As policymakers, you often handle diverse forms of text data, citizen feedback, public consultations, survey responses, and legislative documents. This data, however, is often unstructured and difficult to analyze in its raw form. Text preprocessing transforms this unstructured text into a clean, structured format, making it ready for analysis. By applying techniques such as tokenization, lemmatization, and stop-word removal, we can extract meaningful insights to address public issues effectively. In this session, we'll discuss each technique in detail, highlight its relevance to public policy, and later, explore hands-on implementation using Python libraries like spaCy and NLTK. 1. Tokenization, breaking down text into components. What is tokenization? Tokenization is the process of splitting text into smaller, manageable parts called tokens. These tokens are typically individual words or phrases. Think of it as breaking down a complex policy document into simple, analyzable pieces. Example: imagine receiving a survey response stating, "We need more affordable housing for young families." Using tokenization, this sentence is split into, "We need more affordable housing for young families." Why is tokenization important for public policy? Tokenization allows you to identify key terms such as affordable and housing to understand citizen priorities. Analyze large volumes of feedback by isolating frequently mentioned words and phrases. In our upcoming hands-on activity, we'll see how Python libraries like spaCy or NLTK can make tokenization efficient and accurate. 2. Lemmatization, simplifying words to their base form. What is lemmatization? Lemmatization reduces words to their root or base form. This is particularly useful in policy analysis because people often use different forms of the same word to express similar ideas. Example: consider the sentence, "Citizens complained about rising transportation costs and demanded improvements." After lemmatization, this becomes, "Citizen complain about rise transportation cost and demand improvement." Benefits for public policy analysis. Words like complained and demanded are simplified to their base forms complain and demand, ensuring consistency across the dataset. It highlights central themes, such as transportation costs and improvements, without being distracted by word variations. Later in the session, you'll learn how spaCy and NLTK automate this process for large-scale text analysis. 3. Stop-word removal, focusing on meaningful content. What is stop-word removal? Stop words are common words like the, is, and that do not contribute much meaning to text analysis. Removing them allows us to focus on terms that matter most. Example: take the sentence, "The city must address the lack of public transportation options for seniors." After removing stop words, it becomes, "City address lack public transportation options seniors." Why is stop word removal important in public policy? By eliminating filler words, we can sharpen our focus on key issues such as public transportation and seniors. Enhance efficiency when analyzing large datasets, such as citizen surveys or consultation responses. In our hands-on session, we'll see how libraries like spaCy and NLTK handle stop-word removal with ease. For key benefits and limitations. Key benefits. 1. Cleaner data. Text preprocessing removes irrelevant details, ensuring that data is easier to analyze. 2. Efficiency. Automated preprocessing techniques speed up analysis, even for large datasets. 3. Improved accuracy. Techniques like lemmatization standardize text, improving the reliability of analysis. Limitations. 1. Language-specific challenges. Tools like spaCy are primarily optimized for English. Analyzing non-English texts, such as Japanese or Arabic, may require additional customization. 2. Risk of over-removal. Over-removal of stop words can distort meaning. For example, original, "The government should not increase taxes." After removing not, the government should increase taxes. This changes the message completely. 3. Custom stop word lists. Default stop word lists might not align with public policy needs. For example, words like citizen or government are often essential and should not be removed. 4. Contextual limitations in lemmatization. Lemmatization may not account for context. For instance, running could mean jogging or running for office. Without context, the simplification might lead to errors. These limitations emphasize that while text pre-processing is powerful, it requires careful adaptation to your specific dataset and context. 5. Conclusion, a workflow for public policy analysis. Summary workflow. 1. Collect data, gather citizen feedback, consultation responses, or survey data. 2. Tokenize, break text into individual words or phrases for easier analysis. 3. Remove stop words, eliminate irrelevant terms to focus on meaningful content. 4. Lemmatize, standardize words to their base forms for consistent analysis. 5. Analyze, use the clean data to identify trends, prioritize issues, and draft effective policies. By mastering these techniques, you can transform unstructured text into actionable insights that inform better policymaking. In our hands-on activity, we'll demonstrate how Python libraries like SpaCy and NLTK make this process simple and efficient. Thank you for watching.